ಮಕ್ಕಳೇ ಹೇಗಿದ್ದೀರಾ? Welcome back to the channel. Today I am here with part 2 of the chapter Continuity and Differentiability. Yes, I am trying to learn the language Kannada, but I want to make one thing very clear: the teaching, the learning over here will be done in English only for the convenience of all. But yes, I am learning like you are my student, I am the student of the language, so I'll try to learn it and of course use it more than once in a while in the sessions. But as I said very clearly, I am going to be teaching only in English, that you very well know. Okay, so let's get back to the session now. Session is about the differentiability today. Yes, so we have done the continuity part and we have solved a good amount of questions there. You have seen that, you have solved that. Okay, I'm still waiting for the comments that how many you have solved. I want to see the number of questions you are able to solve every session, and is this number increasing or not? Okay, or if it is not increasing, what can be done to increase that? It's a process, we have to work on it to get better at it all the time. So today's session will be of course on differentiability. As I said, we'll start from very basics. I'll give you also geometric meaning of differentiation. So everything will be discussed, and of course I have brought 10 more questions today to solve in the session. That works out. Okay, and before I start with the session, I have something to tell you. A very wonderful thing happened I think in the last live that I took. So I was conducting a live session, just give me 1 second. Yeah, so I was conducting a live session I think a couple of days back. You must have seen me there if you are part of that live and here in the session as well. You all know, right, we are doing something like leaderboard. So we are coming with a quiz based upon the KCET questions, PUC 2 right now we are doing, I think. So based upon that, we are taking 10 questions in the live and asking you all to solve and participate, and I also explain you the answers if you get it wrong. That's the whole process there. So what happened there, no, these seniors of yours, okay, I don't know the name of the student, his name is Competitive Gaming, the ID is there, and again we have Kush. So you can see, what is it, Competitive is saying, actually I have finished my 12th, just saw your lecture and came to attend. Thank you very much sir for helping me during my prep. Okay, this was the comment from Competitive Gaming. Again, these are the comment in the live chat. You won't be able to see it right now, and you can see here again Kush Varshane is saying, hello sir, I got into RVCE. Look at this champion, RVCE through Comet K, and your launchpad videos helped a lot. We did something for Comet K last year. He's talking about that reference. Okay, so why I am showing you these comments? Very simple reason, because in the session itself, in the live itself, there were a lot of students who were asking, maybe new students or who just joined for the first time. They were asking, is the content given on the platform of Deeksha Karnataka are enough? Enough for what? Enough for PU2, enough for KCET. They were asking, they were like, for example, they are studying for Comet K. So they were, concerned for the content for Comet K. So these seniors of yours are giving you answers, not me, your seniors. There were many more stories. I hope you have seen that on our channel. But yes, all of these achievers studied from us in the year 2025 and got the KCET results, and they got a very good college. There's still the process is going on. You know that very well. So my thing is, I'm very happy about when you ask me this question that is it enough sir, because this shows me that you are actually concerned. So in the student category, there's somebody who is doesn't care what is happening right now or what is happening in the process, but somebody who's concerned means they want to improve, they have a goal. They're not doing good right now, it's okay, but they have a goal and they want to achieve that. So if you are concerned whether it is good enough or not, I'm telling you, it's more than enough if you follow our content properly, if you solve each and every question. That's why I'm asking you to let me know how many questions you can solve every session. Okay, so if you can solve every question comfortably, you can solve all the PYQs of the examination comfortably, means you are prepared, and we're gonna make you do that. Just be consistent, trust the process. Okay, so good that you have a concern, but now after watching some session, try to give more and more tests, try to give, try to answer some questions without taking any help. If you see that being developed after honest hour of study, of course you're on the right track. Okay, I hope you got my point. After honest hour of study, for example, I studied today relation and function. Then after studying that from the content, after solving the question that I gave you, what you can do later, try to attempt some questions without taking any help. Can you solve it? Yes, if of course you will be able to solve it, then you can say yes, the process is working right. Okay, so if you need some help, you can come back and ask me in the comment section of this, you can ask your doubts in the comment section of this video, or you can ask in any video. I will answer to that. Okay, so do not worry, even though it's a recorded session, but you can ask me your concerns in the live. Of course, you guys don't let me go, but in the recorded sessions also, I want your comments so that I can answer that, and so we can have a clear understanding of what is going on and how can we improve if there is a problem. Okay, so this is clear. Now we can start. So what is next? So next is, you can see the agenda over here. We have session outline. I'm going to talk about differentiability. Next we'll go to differentiability in an interval, and we'll have next is derivative formulas. I'll give you some of the formulas and rules. Question practice for this is today only 10 questions. Today only 10 questions I've taken, and problem across all the topics in the derivatives. Clear? This is clear. What is the session outline? What is the agenda today? Got it? Let's start the session now. So differentiability. Okay, it's not derivative. We'll go to that part later. Let's talk about differentiability. It means ability, basically whether a function given to you is differentiable or not. Because usually we think differentiability, sir, can we find derivative? We have the formulas. We will apply the formulas and we'll get the result. So before all of that, the question is the given function differentiable? The question is the given function differentiable? That's my question. Okay, how do you answer that? What's the meaning of this statement geometrically? For example, so differentiability is basically, what is the derivative means? It means instantaneous change. So this means the meaning of this is instantaneous change. Instantaneous change. So rate of change actually. So rate. Why we are saying rate? Rate means with respect to the time. With respect to the time, we are saying instantaneous rate of change. Okay. So change in 1 second. The rate over here, when I said with respect to time, is one of the variable. We can of course have more than one variable. But yeah, if you talk about rate of change, let's say with the time, that part is basically your derivative. That's where the derivative comes in. For example, if I look at the graph, let's say this is the graph. What type of graph is this? I can say parabolic graph. Okay. So if we are talking about, let's say this is a dt curve. This is a dt curve. Distance time curve or displacement time curve, whatever you want to say. So if it is a dt curve, okay, and if you join these 2 points, these 2 points have what? Let's say x1, y1, and okay, I can call this to be x2, y2 actually. x2, y2, and this is x1, y1. Okay, then the slope over here will give you what? The slope over here will give you your average speed. The slope will give me average speed. This is not derivative. This is not derivative. Derivative is what? Is the instantaneous rate of change. Okay, means if I talk about right now, there's a difference in the time, right? This is time axis. It means y2 minus y1 is equal to what? Some time instant. Basically is going to be, let's say 2 seconds, 5 seconds, 10 seconds, whatever it is. But that will give me some time value. But when we go to that instant time, that particular moment of the, in the travel of a car, or whether it is a vehicle or person running, whatever it is, in that motion, if we go about instant, in that particular moment, we have to reach a point. We have to reach a point. And at that point, if we try to understand the slope again, okay, this is going to be a slope then. And this slope over here, slope at that instant, okay, at that instant is called as basically, what is it called as? Instantaneous speed. This was average speed. This will be called as instantaneous speed. Instantaneous. If I want to find speed, right, I can write v instantaneous. I can say it is v instantaneous. Basically the symbol of speed is v, right? So v instantaneous will be your slope of the curve at the point, at that particular instant. And how do you find that? This can be found, can be calculated or found, calculated using derivative. Using the geometric meaning of derivative is what? It is basically, it talks about how much, basically it talks about the slope of that tangent at that particular point, okay, and that value will be giving you the derivative itself. Okay, in this case I have taken a dt curve, so that's why it is v instantaneous, but in different cases the value will be of course difference. Okay, but understand this, derivative means slope of the tangent at that instant for the given curve. I'll repeat myself, derivative means slope of the tangent, okay, for the given curve at that instance. Okay, so basically it means as dy by dx. This is my derivative, and this means what? This implies what? The slope. Now whenever you have a smooth curve, what did I start the entire session right now with? It started with, is the given function differentiable? The question was very simple, is the given function differentiable? Whenever you have a smooth curve, so at any given point you'll have a derivative existing in nature. Smooth and continuous curve is given, it will be of course going to be always differentiable at any point you take. But if you talk about, let's say, a curve with a sharp edge means what? Sharp edge means what? Check here, modulus function. Okay, at this point you check, at this point, let's say this point is 2, this point is 2. Okay, at this point x equals to 2, the function f, if this is, let's say, f equals to mod of x minus 2, this function fx is non-differentiable. So from the graphical perspective, if you can find the graph smooth, simply say it is differentiable. If it is not smooth at that point, it means it will become non-differentiable. Reason is very simple, there is a logic behind it. What's the logic? If you approach, one second, so basically I'll teach you everything over here only. Okay, in the graph only I'll teach you everything, just pay attention. If you approach this curve, this point from the right hand side, what's the slope, sir? This is the slope, right? Correct or not? This is the slope. And if you approach from this side, one second, I need to have some water. Okay, so I was saying what? Thank you for waiting for me. So what I was saying here is, this side you check, it will be a slope, right? And how could you find the slope? Remember, this slope, if I call it to be m1, you find using this angle. Let's say this is theta 1, or let's say this is alpha, I'll call it to be tan alpha. Right? And for this side, before, if you go before, this part will be your other angle, let's call this to be angle beta, and for this side, let's call the slope to be m2, it has to be tan beta. Now you only tell me, can this slope be ever equal? Can you say that m1 will be equal to m2? Can this ever be equal? No, sir, it can never be equal to each other. Reason is very simple, because this is a positive slope. If you know the slope part, okay, this is a positive slope, this is a negative slope. How positive? Alpha, the angle is acute over here. Sorry, I did a mistake over here. I have taken this as the beta. That's incorrect. Okay, I made a mistake, sorry. Okay, so this is the angle actually for this line. No, this is the angle, obtuse angle. This is your beta. The obtuse angle is your beta. So alpha is acute. I hope this is visible. This is not visible, I guess. So let me just erase this point. So alpha angle is acute actually. So acute means tan alpha is positive, wherever the tan beta is going to be negative because of the obtuse angle. Second quadrant, tan is negative. Okay, so my point over here, clearly, what happens here is, this slope value can never be equal. So this m2 is actually called as right hand derivative, and this m1 is called as, m1 is called as right hand derivative, and this m2 is called as left hand derivative. They are not equal. Hence we can say the given function this at the point x equals to 2 is non-differentiable. At the point x equals to 2 is non-differentiable. So what we have learnt in this particular slide, there too much information. I want to give you one by one. First thing we learnt about, a function is differentiable if curve is continuous and smooth. Okay, the function is differentiable if, first thing is, if curve is continuous and smooth. Secondly, what we learned, we talked about the difference between instantaneous rate of change and average. Okay, we learned about what is V instantaneous versus average, V average. That's what we learned over here, right? So difference between the V average and V instantaneous. Okay, so V instantaneous part is called as, this V instantaneous part is called as the derivative. This represents your derivative dy by dx. Second thing, and last we saw how can a function be non-differentiable. How can a function be non-differentiable? Using which concept? Using the concept of LHD not equal to RHD. What is LHD and RHD? Left hand and right hand derivative. Left hand and right hand derivative. This is my conclusion of the particular slide. Too much, but I'm telling you, if you understand this much, this thing clearly, your session is over. Okay, rest all will be application of this whole thing only. Okay, what is the derivative? Is the slope of the curve at that given point. What is how can we say the function is differentiable? If the curve is smooth, then it is differentiable. If it has a sharp corner or edge, we'll call it to be non-differentiable. How do you find that? Using this dy by dx. How do you find this derivative? Using dy by dx. Okay, and when can you say non-differentiable? If you have LHD and RHD not equal. I've taken example of fx, the function f equals to mod of x minus 2 and explained it to you over here, given the pointers here as well. I hope you had fun learning this part. Okay, I know I took it longer than it should be, but I wanted to explain everything in one go. That's why I've taken over here. Now we'll go into particulars. I hope this is clear. I hope this is clear. This is very, very important. Okay, what I gave the information right now is highly important. You should remember these words only. If you remember it properly, don't worry, in the session slides I have written the same thing. Okay, but right now I wanted to give you introduction in a not only just briefly, in a very explained and detailed manner. Okay, differentiability of a function at a point fx be real valued function defined on an open interval ab, and let the point C belongs to the interval a and b, then fx is said to be differentiable or basically derivable is when this value, derivative from the first principle, is called as exist. When this value, then this limit exists, and this limit is called as derivative from the first principle. When this value exists, it's a finite value, then we call this to be actually differentiable. For the given function fx becomes differentiable. Okay, got it? It's fc actually. Yeah, this is the same thing you can find from here. F dash of c means, so f dash of c is basically derivative of the function at the point c is basically f of x minus f of c divided by x minus c. This is the formula of derivative, not like the formulas for sine, cos, tan or polynomial function. That all comes from this principle only. All the value you see, all the formula you see comes from this principle. Is called as from the first principle of derivative. This is called as first principle of derivative. First principle of derivative. I hope this is clear. I hope this is clear. Okay, correct? Alright, and we represent it like either we write it as f dash of c or d of c or d of fx by dx at x equals to c. This is a different way of noting or writing down derivatives of a given function f at the point c, at the point x equals to c. This is clear. Let's move on. Right hand derivative. Next is right hand derivative. As I explained you, whenever you're trying to approach the point from the right hand side, okay, we saw this case right now. Trying to approach this point from this side, this part is called as right hand derivative, and this side, if you try to approach this point from this side, is called as left hand derivative. So the fraction under the limits, the things will remain same. What is it? F of x minus f of c divided by x minus c. This will remain same. The first principle will remain same only, but approach this c from the right hand side. This is the representation or the symbolic value, the formula for right hand derivative, also called as very commonly RHD. Okay, and we represent it like rf dash c or f dash c plus, okay. So, and how do you find that? In the limits, you can simply use this formula, c plus h minus f of c divided by h. So basically, wherever your values, x was there, replace the x by c plus h, replace the x by c plus h, and this will become simply h. Check this out. If I take x minus c over here, replace x by c plus h. So c plus h minus c. C and c is cancelled. What I'm getting here? Only h left. Only h left. So replace the value x. I will write it over here. Replace x by x plus h. Replace x by x plus h, and you'll have the answer, sorry, c plus h, my bad, not x plus h, c plus h. Okay, replace x by c plus h and the limit h tends to 0, limit h tends to 0. Okay, this is not positive anymore, we already taken the positive part here. It's going to be c plus over here, and this will be h tends to 0, not positive. Already taken here the positive part. This represents your, again, RHD only. Got it? How do you find that? In the limit, this limit, replace x by c plus h and change the limit x tends to c plus 2, h tends to 0, and you get the answer as this. This limit can be solved, and from there you're going to get the result for RHD, and that RHD should be equal to what? Should be equal to your LHD, your left hand derivative. And when they are equal, see here, this is f c dash means RHD, and this becomes LHD. When they are equal, then you call what? When they are equal, you call the given function to be differentiable at the point C. At the point C. How do you find the same approach? In this case, you can replace x by c minus h. Replace x by c minus h, and h will tend to 0. So this is the limit. Remember, this is the derivative from the first principle. I can write this as first principle of derivative. In the first principle of derivative, you're going to replace x as c minus h. C minus h. Check here, it will become simply minus h in the derivative in the denominator part, and this will become c minus h minus fc. And simply solve this for limit, you get the result, and that will be your LHD. They should be equal, and when they are equal, you call the function to be differentiable at that particular point. Clear, right? Clear, no? A function is said to be differentiable function if it is differentiable at every point in its domain. At every point in its domain. For example, if I talk about this curve, differentiable or not? Yes, sir, differentiable. If I talk about this curve, differentiable or not, sir? Non-differentiable. This is differentiable. Parabolic curve is differentiable, whereas the modulus curve is non-differentiable. So in the domain of that particular function, at every point, if it is differentiable, it means if it is smooth everywhere, you can call it to be simply differentiable, otherwise non-differentiable, as you can see in the case of modulus. Clear? That's why I told you that that particular first slide was very, very important. I know it was longer, but it is highly important to make the mood right, make this starting right for the session. Okay, if a function is differentiable at each x belongs to R, then it is said to be differentiable everywhere. Okay, means basically what does it means? Entire number line, right? Entire number line, that's what it means. So if it is differentiable everywhere in the entire number line, basically all real numbers, then it will call as differentiable everywhere. Clear? This is clear. Few things to remember, not very big deal. The relation between continuity and differentiability. Here 2 points are very important. This, okay, and this. If a given function is differentiable at a point, if you have the function is differentiable, to understand that it will be continuous. So if you have differentiable, then continuous will come automatically. Okay, if you have non-differentiable, if you have non-continuous, means basically discontinuous, it will be of course discontinuous. There is a difference, DC and CD. Differentiable means always continuous. Differentiable means always continuous. Non-continuous, basically discontinuous, will become non-differentiable. Okay, differentiable means always continuous. Discontinuous means non-differentiable, or non-continuous means non-differentiable. So 2 points here. If a function fx is differentiable at a point, it will be continuous as well, and if a function is discontinuous at a point, it will be not differentiable at the point as well. I hope this is clear. Please check. Okay, and for other one, it will be may or may not. May or may not. For other cases, let's say it is continuous, but then it will be you have to check for differentiability. These 2 points, no, you have to check. You're not sure. You're not sure. Okay. Let's say I have continuous function. Okay, but it might not be differentiable. For example, modulus. Is a modulus function continuous or not? It is a continuous function. Differentiable? No. So a function is continuous, it may or may not be differentiable. A function is not differentiable, may or may not be continuous. Here, check this out. Same example. This function is not differentiable, but it can be continuous also. And you can have an example where it is discontinuous also. Example, I can say like this. Like this. At this point, the function is non-differentiable and non-continuous. Please check, because left hand limit will be different and right hand limit will be different. So it is not continuous and non-differentiable. Both is true. Getting my point, right? The graph here is, there's a break in the graph. Break means it cannot be differentiable and it is not continuous also. But in this particular case, you see it is continuous but not differentiable. So the two cases you see, question number, the point 2 and point 3 are the case of not sure. You have to check this out. You have to solve the question to check it out. But the first and fourth point, if it is differentiable, it will be continuous. If it is not continuous, it will be never differentiable. Never differentiable. Please check. So all the 4 points are clear. Okay, let's move on. Now this is again a very, very important point over here. If they want to give a very tricky question to you, if they want to challenge you, they can, they can give you on this hint, and if you don't remember this, you have to spend a lot of time to solve the question. If you don't remember this point, you have to solve lot of steps to get the result. I'll show you. F dash of a minus 0. What it means? It means left hand derivative. Yes or no? It means left hand derivative. Is a finite number, then fx is continuous at x equals to a from left. What does it represent, sir? It represents LHD, right? It represents, I think, LHD. Correct, no? So if f dash of a minus 0 is a finite number, then what happens is fx is continuous at x equals to a from the left side, okay? And same thing, if f dash of a plus 0 is a finite number, then fx is continuous at x equals to a. Now it might be confusing to you, sir, why does it go like that? Think about it. So the statement is, the clarity over here I've given, a finite left hand derivative. A finite left hand derivative. A finite, what is this called as? Left hand derivative, right? So a finite, is it a finite value? Yes, sir. So a finite left hand derivative implies, what it says is that the left hand limit of the function is actually equal to the value at that point. It means your LHL actually is equal to the function value at a. The function value at a, okay? Basically, if I talk about like this, let's say the interval is b to a. Interval is b to a, okay? For this particular case, the first case. Then what happens here? Remember the continuity part. At the point A, if I'm talking about, let's say, inclusive, okay, at the point A, what should happen? The left hand limit should be equal to function value at A. The left hand limit means from this side, the left hand limit should be equal to function value at A. If that is the case, it means I can say that the function is continuous at the point A. Yes or no? Yes, sir. Please check. So the finite left hand derivative implies, it tells us that the left hand limit of the function is actually equal to the function value at that point. And in the case of the second case, this thing changes. It is A inclusive B. In this case, what happens? What does this represent? This represents RHD. So RHD is finite number. Then what happens is fx is continuous at the point x equals to a, because the RHD finite implies that RHL, right hand limit of the function at the point A, RHL at A is equal to the function value at A. In this case, we had LHL at the point A equals to function value, and we'll have in this case RHL at the point A should be equal to function value. Is it clear or not? So you don't have to worry about finding the left hand limit and check for the f of a. If you actually have been given in the question that left hand derivative is finite, it means that it will be continuous from the left side. Okay? If your RHD is finite, it means continuous from the right side. Is that clear or not? Is that clear or not? Left hand derivative is finite. I'm not saying limit, I'm saying derivative. Left hand derivative is finite. It means, it implies continuous from the left. If the right hand derivative is finite, continuous from the right. Got it? Very important. If this question comes, you should remember these points over here. Got it? Can I move on? Let's see. Next is differentiability in an interval. Okay, so again same thing over here. We'll have to look for the interval which is closed and open. This is closed interval. It is closed interval and we have open interval. Let me show you open interval first. What it means for open interval? It means if I say I have point A over here and point B over here, I call A and B both open. That's how we represent open intervals. So at the point A and B, we don't have that is not part of the domain, okay? But between the point A and B, we have infinite number of points. We have infinite number of points. So for the function to be said that it is differentiable in the open interval AB, what is the condition? The condition is it should be differentiable at every point. What's the meaning of that? It means from the left hand side and right hand side derivative, it should be equal at every single point. Okay? For every point, the LHD should be equal to RHD. Please check. A function fx is said to be differentiable in an open interval if it is differentiable at all points between A and B. Okay? Now let's get back to the closed interval. Open is clear. Open is clear. Okay. So for closed interval, the things will change. For closed interval, of course, this should be there. Please check. This means that this is the same thing, right? Fx is differentiable from both sides at every point between A and B. So for the closed interval, this is the first 3 points is for the closed interval. Closed interval. Okay. So in the closed interval, this point, of course, is a common point. Means fx is differentiable at the every point from both sides in the interval A and for the all the points between A and B. That is clear. Now for about at the point A and at the point B, what happens there? So at the point A, we should have right hand derivative existing in nature. Please check. The differentiable, it should be differentiable from the right side. At the point A, we should have right hand derivative finite, and from this side we should have left hand derivative. Getting my point? At the point B, it should be differentiable from the left side. Means that this is, what is this called as? This is my LHD. This should be finite, and at this point my RHD, what does this means? This means RHD should be finite. So for us to let me conclude now. A student asked me, sir, when can we say a given function is differentiable in a closed interval AB? My answer to that will be, first thing is it should be differentiable in open interval AB. First point, differentiable in open interval AB. Now point number 2, at the point A, which is my left point, okay, at the point A, the right hand derivative should exist finitely. Means the RHD value should be a finite value. That's my point number 2. And point number 3, at the point B, I should have LHD finite. Okay, I should have left hand derivative finite. Is that clear or not? Simple enough. I have given you summary. First, it should be differentiable in the open interval AB. Second point, RHD at point A should be finite and LHD at point B should be finite. Is that clear or not? Yes. Any doubt you have, let me know in the comment section, or right now you can say, sir, differentiability in the interval is clear. Let me know. So differentiability, you can write diff in closed interval, clear. Let me know in the comment section right now. I will check your comments. Differentiability diff in closed interval, clear, sir. It's important. I'm telling you, it's very, very important from the question point of view. Diff in closed interval, clear, sir. Give me a comment right now. Okay. Let's continue from here. Now derivative formulas. Now we are moving towards solving questions and completing our session. Before I start the questions, I want to give you some formulas also, right? So start from the very basic formula. What is that? We have seen this function a lot. Y equals to a times of x power n. A times of x power n. Have you not seen that? Yes, you have. Derivative of this function actually, what's the symbol of derivative? Symbol of derivative is, sir, y dash. Symbol of derivative is y dash. So I'll show you the derivative later. Okay, I can show you right now only. Y dash will be given by, this a is a constant, we'll keep it outside. This n will move in front, so I'll have n, and this x power will become n minus 1. So a into n into x power n minus 1 is my derivative. Now I'm going to list out all the functions, okay? If I forget any, you're going to let me know in the comment section. Will you not? Please, I'm telling you, if I forget any question or any functions to write over here, you have to tell me in the comments, sir, please give me formula for this also, okay? Function number 2, I can write here second function to be let's say y equals to my favorite e power x. Third function to be y equal to ln x. Okay, another favorite. Fourth function to be y equals to log of x, sir. Log of x, sir. Okay, log of x. So let's write the base to be a here, unknown base. Log of x with the base unknown. Okay, question formula number 5. Formula number 5, anything I'm missing? Exponential is done, logarithmic is done. Of course, I'll have trigonometric functions. We'll see that later. Right now. Okay, so I think fifth one, can I take trigonometric function directly? Okay, let's do that. So we'll have trigonometric function as y equal to sin x. Okay, sixth one will be y equal to cos x. Seventh one will be y equal to tan x. Okay, and eighth one will be y equal to cot x. And ninth one will be y equal to, I think, did I forget anything? Yeah, cosec x. And we have 10th one as y equal to sec x, right? Sec x. And 11th one will be what? Can I take 11th one also? Yeah, very commonly used, tan inverse of x. One of the most favorite derivative, tan inverse of x. Tan inverse of x. Okay, this is one of the favorite. I'll give you, don't worry, I'll give you more inverse functions as well. So sin inverse, tan inverse is the most useful one in your examination point of view, but tan inverse will remember right now. Tan inverse also is there, 1 upon root of 1 minus x square. Okay, 1 upon root of 1 minus x square is your sin inverse. Again, if you want to have cos inverse, simply write minus 1 upon root of 1 minus x square. We'll see that later, don't worry. For right now, let's write the derivative of these 11 functions. They are highly important and useful for us right now. And if I recall many more, I'll give you while doing the questions also. Please check. For this function, no change, sir. Y dash equals to e power x. E power x. If I had e power ax, let's say if I had y equals to e power minus ax, e power minus ax I had, then the derivative in this case will become y dash equals to minus a times of e power minus ax. Minus ax. I hope this is clear. Simply this is chain rule. We'll learn that, don't worry, we'll learn it later. But if you have a constant multiplied over here to the variable x, you have to differentiate that also, you get the answer as minus a. Right now, please accept the formula. I'll teach you when I go to the theorems of the derivative. Okay. Now, next one will be y equal to ln x. This is very simple. Simply y dash will become equal to 1 upon x. What is y dash? 1 upon x. How about this log of x with the base a? Not difficult at all. So y dash will become 1 upon x times ln of a. Ln of a. Okay. So if you have the base unknown over here, it will become 1 upon x ln of a. Let's say sometimes we just write it as log of x. If you don't write anything, if I write like this, log of x, what it means? It implies log of x to the base 10. Nothing written means what it means? It means the base is 10 actually. So in that case, what will happen to this derivative? It will become 1 by ln 10. Okay, if you are looking for derivative of this, right? The derivative will be, if I call this to be, let's say, function y, derivative will become what? Derivative will become 1 by x ln 10. 1 by x ln 10. Because if they don't write anything, it means the base is 10, and if the base is 10 means x ln a, in place of a, what will have? You will have 10. I have to erase this because of course I have to write for these over here, but okay, fine, we'll erase it later. Right now, let's continue. Y equal to sin x. So y dash will become equal to cos x. Y dash will become equal to cos x. What about cos x? So y dash will become equal to minus sin x. Minus sin x. Okay. How about tan x? So for this you'll have y dash equals to sec square x. Very, very useful. Use a lot. Okay. Let's erase this one and then continue the formulas. Let's erase this one. Okay. I hope you got it right. Log with the base 10 is simply y dash equals to 1 by x ln 10. Or nothing is written in the log base. You can simply take 1 by x ln 10 only. Cot of x will be same this. Y dash equals to minus cosec square x. Okay. That's for, so for tan x we have sec square x. For cot x we'll have minus cosec square x. For cosec x, we'll have y dash equals to minus cosec x cot x, okay? And for sec x, we'll have y dash equals to, it'll be plus, okay? So plus sec x and tan x. So for sec x derivative is sec x tan x, and for the cosec x derivative is minus cosec x cot x, okay? Formulas are listed over here now. Great. What about tan inverse of x, sir? Very, very important, very useful, best friend for your derivative, even in the substitution of integration. 1 upon 1 plus x square. 1 upon 1 plus x square. For sine inverse, you have this 1 upon root of 1 minus x square actually. And if you take the case of cos inverse, this will become simply minus 1. Right now this is plus 1, right? It will change to minus 1. Is the formulas part clear or not? Okay, I'm not giving you proof of this formula is not required actually. You can prove it using the first principle. If you want to do it, you can look up and you'll get the result for all the derivatives. Actually, you can find the derivative of each of the formulas using first principle or using the basically limits. Okay, this is clear. Can we move on to next one? Okay, now we are going to talk about some general theorems. They are very useful to solve complicated questions. The first question only that you're going to see will be based upon these theorems only. Okay, so sir, still questions are not started, don't worry. Just last topic where we'll talk about the theorems, then we'll start the questions only. Okay, the differential coefficient of a constant. Sir, what it means? What it means is basically if you differentiate a number, give me a number, any number. Sir, 5. 5 is the easy one. Give me a difficult number. Difficult number. Sir, log of, sir, what is this? Log of 5. Let's take log of 5. What is the answer, sir? What is the answer? Answer is over here, 0. Any constant number you take, whether it is fraction, whether it is negative, doesn't matter. Any constant number, derivative is always 0. Derivative is always 0. Basically, derivative of a constant k is equal to 0. Is equal to 0. Okay, whether it is irrational, doesn't matter. If it is a constant, answer is 0. Got it? Okay, so if you have a constant multiplied over here, what if you have a constant multiplied over here? Then you're going to take this constant outside and continue with the differentiation. See, the c is taken, constant is taken outside, and the differentiation is continued. The differentiation is continued. This is the format, right? Remember we learned this, d of fx by dx is the way of writing the derivative. You can also write like this also, c times of this, or like this, c times of f dash of x. This also is true. Okay, same thing it means, the same different symbol, that's all. Okay, so next what we have, next is the product rule. Whenever you have two different functions, two functions possible, I can have x square sin x, I can have x square sin x, I can have x ln x, okay, and so on. I can have two different functions multiplied to each other and you're asked for finding the derivative. How do you deal with those kind of questions? How do you deal with them? Simply use the product rule. Simply use the product rule. And how do you use that? So preference order, things like that, nothing. Nothing as such, just differentiate one function at a time. Check here. So we have differentiated g first, kept f as it is. So g is differentiated, kept f as it is. Next what we have, differentiated f and kept g as it is. G as it is. Basically what it means is, if I want to simplify this, derivative, okay, I'll do it again for the three functions also, then we'll continue how to give you simple symbols. So if you are asked to multiply, let's say there are three functions multiplied in this case. We have three functions, f, g and b. Okay, three functions are there and you are asked to differentiate their product. How do you do that? First differentiate fx, next differentiate gx, next differentiate bx. So what it means actually, I'll show you. Let's say I can write this fx as simply f, write gx as simply g, and hx or bx as simply b. You are asked to differentiate. That's a symbol of differentiation. Yes, you all agree? It is dash. It meant in determinant, sorry, in matrices it means transpose, but in this case it means derivative. Okay, different symbol. All right. Do not worry. If you write in the questions, the teachers will understand which symbol you're talking about. Derivative means this symbol. Now how do you differentiate this? So you cannot differentiate f first, let f dash and g be written as it is. Differentiate first. Sir, any order, can we write g dash first? Your choice. You can write any of them first, doesn't matter. There is no preference in the case of product rule. In other rule, which is called as quotient rule, there is a preference. But in the case of product rule, there is no preference. If you don't want this, okay, fine. You don't want this, I want to erase this. Okay, sir, let's erase. We'll write the derivative of g dash first, sir. So we'll write f g dash b. We'll write f g dash b. Next, what is going to happen? I can write, sir, b. I want to write b first, right? F as it is, g as it is, and write b dash. And you want to write last what? Sir, I want to write last f dash. Right here, f dash gb. It does not matter because they're all in the summation, right? I can simply put this here first and this last. Does it matter? No. So you can take in any preference order. Just understand, you have to differentiate one function at a time and keeping the other two function as it is. If it is 3 function, 4 function, 5 function, does not matter. The continuously same rule will apply. Differentiating one function at a time, keeping the other as it is. Is it clear or not? Clear or not? Yes, it is clear. Okay, so this is done. Let's move on now, sir. Now we have the quotient rule. Okay. If you have two functions in the ratios, I can write here f by g. Asked for derivative. What will happen is you're going to differentiate f first. In this order is given. This is given the preference. Okay, you're going to differentiate f first. So keep g as it is and differentiate f. So it's called as g f dash. Next will come a minus sign. In case of quotient rule, you'll have a minus sign. This time you'll keep f as it is and differentiate g. Please check the order. First is differentiated as f dash g as it is. Next is g dash f as it is divided by g square, divided by the denominator square. That's the formula. That is it. This is called your quotient rule. Very, 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 very important. Not only for this chapter, not only for exam point of view, not only for some use in the questions, but also in the integration substitutions. I'm telling you, more than once, more than twice, you'll see a lot of questions in the substitution of integrations, whether it is dealing with indefinite integral or you're dealing with different integral, you'll have this application a lot. And don't worry, I'm going to give you a shortcut also for this. We have started a shortcut series, right, in the channel. You can follow that as well. I'm going to give you a shortcut wherever it's possible to save some time for all of you. Okay, so there's a shortcut for this. I'll give it to you. It uses determinant. So it is given like this actually. So if you have a fx plus b and you have over here, let's say c gx plus d, you want to differentiate this, okay, simply given as a b c d, okay, a b c d, one second, no, I think it is a b c d, right? Should be, yeah, one second, it should be, the b should come here actually. This is change. Let me remember. I forgot the coefficient actually. It should be a b c d. Yeah, it should be a b c d like that, and you'll have over here f dash of x divided by this whole thing the square. The denominator the square. This whole thing. That's your shortcut. That's your short trick. If you don't want to use it, don't worry, I'm going to show you the application also. Looks difficult right now, but do not worry, sir. Do not worry, sir. It's a shortcut trick. We can be very, very useful, especially when you're dealing with a question of integration and you want to reach to the substitution, right? Can be used. Okay. So can be used in definite integral, all the places. Right now, your energy should be over here. That's it. Just know the formula of quotient rule, that's all. Keeping g as it is, differentiate f, minus keeping f as it is, differentiate g divided by g square. That's the quotient rule. Good enough for us, sir. We don't need shortcut. Okay, we'll see that later. we'll see that later. I'll come up with a shortcut series, and in that I'll give you example also how to solve it. But right now, just for some student wanted to ask me in the comment section, sir, what's the shortcut sir for this question tool? I'll get stuck in that. That's what I've given you. Look, whenever there's a shortcut, you have to remember the trick. Concepts can be, don't have to memorize it, mugged it up, because by practice it'll come to you. But for shortcuts, you have to remember the formulas and the tricks. So this has to be remembered. I'll check this part. I think this should be correct only, but I'll just cross check this determinant. The order might be different, okay, but I think this is pretty much correct, okay. But I'll cross check for your reference whether this determinant is right or not. It is right only, I think, okay. Let's move on to the chain rule, one of the most important rule. Again, I'll show the first question based upon this only. First question that I'm going to solve right now will be based upon chain rule. How do you solve this? Okay, this is written all over here. Lot of things are written over here. Might be confusing. I'll take one example and this will help you a lot. Okay, of course this is for your reference. You can read the notes. But let's say if I have a question, y equals to sine e power x square. The question is y equal to sine e power x square. Y equal to sine e power x square. Derivative states that you have to differentiate the first function outside. Okay, so keep it like this. Y dash will be given by differentiate sine. Sine becomes what? Cos. So cos times of e power x square. It is not over yet. The question is not over yet. Okay, you just differentiated the first function sine. Next step is to differentiate what is the next function. What is the next function? Exponential function. What is the next function? Exponential. So right here multiplication, so a dot, and differentiate exponential function. You know that result remain as it is. So e power x square. It's not writing is, this represents derivative of this. Okay, this is my first sine derivative is cos, derivative of e power anything is same number, right? Is it over? No. Differentiate the function that is also there after that. So first function was, this is my first function sine, e power is my second function, and x square is my third function. So differentiate x square also. The derivative of x square will become what? 2x. So my final answer will actually be, have a look. My final answer, y dash is nothing but 2x e power x square cos of e power x square. That's my final answer. That's my final answer. 2x e power x square cos of e power x square. Clear or not? Okay, let's continue. Achha, before I move on, I want to show you this as well. Please check. So this is if you want to differentiate y with x, this is a conceptual part. How do you solve it? But in this case, if I want to show you, the chain starts progressing with this thing is common. Please check. This thing is common. dy by dx, we were asking, what do we wrote? dy by du and du by dx. Why do we do that? Because sometimes this is, the function will be given in terms of, let's say, other variable. Okay, let's say you want to find the y is given as sine u. The y is given as sine u. And what are they asking? They're asking you dy by dx. Can you differentiate? Is there a variable x in the sine? No, sir. Then how do you differentiate it? You have to write it like this. Differentiate sine u like this? No. No, sir. You have to differentiate this with u actually. With u, the letter, the variable u. And then continue here, derivative of u with x. This is called as chain rule. This is called as chain rule actually. Please check. So this will become cos u and this will be as it is du dx. So this is the final derivative of dy by dx, where y is equals to sine u. Okay, this is the basic concept of chain rule. Okay, so you continue like this. For example, I want dy by dx. I want the value of dy by dx. But y is in the format, y is a function of u. Y is a function of u. U is a function of v. Okay, and v is a function of x. Y is a function of u is a function of v, and v is a function of x. So I have to differentiate like this: y with u with v, and v with x. Y derivative with u derivative with v, and v derivative with x. We have done it over here, right? Sine derivative with e power x square, e power x square derivative with x square, and x y derivative with x. Getting my point? Basically, my y equal to sine u, where what is the value of u over here? If I compare this and this, if I compare this with this, what I get the value of u? My value of u is actually e power x square. E power x square. What's the value of actually here? This is value of u. What's the value of v? V value is x square. V value is x square. That's why you took the derivative of y first, y as cos, derivative of e power x square as simply e power x square, and derivative of x square as simply 2x. That's why you have 2x e power x square cos of e power x square. I hope this is clear now. I hope I have not confused you. Let me know if you have a concern, if you have anything to ask me in the comment section right now. I will again come up with a session where I can help you to resolve that concern. I'm telling you, it's very, very important. Okay, can we continue now? Okay, so chain rule is over. Let's get to the questions. Let's start our 10 questions now. We'll solve it and wind up the session. What is it? Now we have to go fast. But don't worry, I'll not skip any of the steps. Differentiate sec of tan of root of x. Sec of tan of root of x. How many functions? 3 functions. Differentiate sec first, so write here y equal to sec tan root x. Now if I want to know, I can actually take tan as the other function v and all. Okay, so I can have an approach. I will not do that because it's of no use. I can simply write a function, let's say u as tan root x and differentiate. Okay, and I can take v as root x. So my question will become actually, my dy by dx will become dy by du, du by dv and dv by dx. We can do all of that. If you want, try this approach and give me the final answer. I have taken here, my u value is tan root x and my v value is basically root x. Apply. Okay, so I can write, okay, not tan root x, simply tan v. My bad, not root x, no, tan v. This is v. U value is tan v and v value is root x. U value is tan v and v value is root x. Okay, use this formula, the chain rule formula, to get the result, or I'll use this constant. Please check y equal to, first have to differentiate what? First have to differentiate what? Sec. Yeah. Y dash I will write here, y dash. Okay, differentiate sec. What do you get for sec? You get sec of this angle whatever you have, so sec of tan root x and times of tan root x. Do not make it tan square. Do not make it tan square. It is not tan into tan. It is tan of. This is the value inside the tan. It is not tan into tan. It is not tan root x into tan root x. There's a difference, okay? Tan root x into tan root x is tan square of root x. Again, it will not become tan square or of x actually. It will not become. There's a difference, okay? I hope you get it. There's a difference. What if we have tan of tan root x? This is derivative of sec. This whole thing is the derivative of sec. I'll go to the next derivative now, which is for tan. I'll go for the next derivative, which is for tan. Tan derivative is what? Sec square of root x. Sec square of root x. This is the derivative of tan. Is it over now? Of course not. Of course not. Differentiate root x also. What is the root x differentiation? Take x value. Root x means x power 1 by 2. Root x means x power 1 by 2. Differentiate that. What do you get? Formula 1 by 2 times of x power 1 by 2 minus 1. Right? What it becomes? 1 by 2 x power minus 1 by 2. So this will come in the denominator. So what you'll have? You'll have here, I can write this bracket, and this bracket will have 1 by 2 root x. Please check. Please check. 1 by 2 root x. Basically, I can write this as 1 by 2 x power minus 1 by 2 minus 1, which is minus 1 by 2. It will come in denominator. It will become x power 1 by 2 in the denominator. Simply root x. My final answer, y dash equals to, this will come in front. So 1 by 2 root x is the value in front, and we get, what is it? Sec of tan root x, tan of tan root x, and sec square of root x. Now this is my final answer. Have a look. Done? Easy, very simple. Okay, question number 1 is done. If you have a doubt, you let me know in the comment section. Apply your own concept of this also. I've taught you this. Chain rule you can apply, get the result. I've done it directly also. 2 different methods, you can use it. You'll have a same result. Question number 2. Prove that the function f given by fx equals to mod of x minus 1 is not differentiable at the point x equals to 1. Very simple, sir. Graphical approach. Graph of this function. That's the graph. X equals to 1. Right or not? I've actually given you this explanation in the first slide only. This angle is alpha. This angle is beta. Tan alpha is a positive value. Tan beta is a negative value. It means LHD is not equal to RHD. At which point? At the point x equals to 1. Hence, non-differentiable. Or if you want to say, what is it? Simply at a sharp corner at the point x equals to 1, non-differentiable. But this is the steps. This is another step also. This is the graphical approach. We have approach number 2. This is method 1. Let me go and teach you method 2 also. Define the function. Define the function. If you take the values of x all equal to or greater than 1, all x equal to or greater than 1, what you'll have? You'll have this as x minus 1. The function will open with a x minus 1. But if you look for the value which is less than 1, what will happen? It will become negative, right? So you'll have here minus sign of x minus 1. Basically, it will become minus x plus 1. Right? It will become minus x plus 1. Okay. Have a look. Now the things changes. If you look for derivative now, what happens? For x greater than equal to 1 and for x less than 1. For greater than 1, this will become 1, right? Derivative of x is simply 1. Derivative of x is simply 1, and for this will become simply 1 minus 0. How much is that? 1, right? 1 minus 0 is 1 only. Okay. Similarly, differentiate this for x less than 1. For x less than 1, differentiate minus x plus 1. Differentiate the derivative of minus x is what? Minus 1. Again plus 0. What is the answer? Minus 1. So this represents your right hand derivative and this represents your left hand derivative. You can clearly see that left hand derivative is minus 1 and right hand derivative is plus 1, which is not equal to each other, hence non-differentiable. Hence non-differentiable. Now which method you want to choose is your choice. Whether you want to choose a graphical method or you want to choose a normal algebraic method, your choice. Define the function at the point given to you x equals to 1 and differentiate to get the LHD and RHD. You can show they are not equal to each other because one value is coming as 1, other is coming as minus 1. Hence non-differentiable, sir. Hence non-differentiable, sir. Okay, 2 is done. Question number 3 now. Achha, where will you get the class notes? It's very important. Class notes is available in the WhatsApp channel. You have to join that to get the class notes. Okay. Prove that the greatest integer function defined by fx equals to gi of x is not differentiable between 0 and 3 at the point x equals to 1 and x equals to 2. Of course. Why, sir? If you remember the graphical approach again, 1 and 2, what will happen? At 1 is 1 over here, 2 over here. At 1, the graph goes like this. I hope you have not forgotten. The graph is closed over here, open over here. At 1, it becomes closed over here, open at 2. At 2, it is going to be closed over here, open over here. Okay. This is 1, this is 2. This is my graph of gi of x. This is nothing but greatest integer function of x. Greatest integer function of x. Okay. GIF of x. GIF of x. Okay. Now please check. I'll continue like this. Just a second. So if you check at the point 1 and 2, at the point 1 and 2, your right hand limit and left hand limit are not equal. Check here. This is your right hand limit or not? Yes. What is this? Your left hand limit. Okay. So you're at the point at this point LHL is nothing but 1. Sorry, 0 actually. My bad. Very bad. Okay. left hand value at the point 1 is actually 0. Okay, this is 0, and your RHL value is what? Your RHL value is 1. Okay, and at this point, what you say? At the point 2, again, what happens at the point x equals to 2? Again, your LHL value is 1, and the RHL value is 2. Are they equal? They are not equal. It means what? Limit does not exist. Limit does not exist at x equals to either 1 or 2. Whether you take the point at 1 or 2, the limit value does not exist. Remember, limit, what is the condition? LHS should be equal to RHL, right? Not equal. LHS is 0, RHL is 1. It means limit. The basic understanding is, if you remember, if this question is coming as MCQ, okay? Understand this very clearly. Any greater integer function will have limit non-existing at x belongs to integer. For all the integer values, okay, in the domain, limit does not exist. For all the integer value in the domain, the limit of the GIF function does not exist. It means, what happens? It means non-continuous, sir. What is the continuity definition? Continuity definition is the limit becomes equal to the function value at that point. Okay, so limit does not exist. It means, what it implies? Non-continuous. What it implies? Simply non-differentiable. Got it? A function which is having the limit does not existing in nature will be non-continuous because there is a break in the function, and it will have non-differentiable condition as well. Okay, automatically non-differentiable, so non-continuous, non-differentiable. Got it? Simple enough. If you remember this property, if it is MCQ, simply you can write the answer directly. But if it is a subjective question, you have to go and show the approach. Clear or not? Clear or not? Yes, all of you agree with me. Let's move on. Question number 4. Yeah. Derivative. This is something called as implicit function. Implicit function. What it means is, it means subject is not given. Subject is not given. Subject of the equation, basically, for any given equation or function, there will always be a variable, right? Y equal to this, x equal to this is not given in this case. Subject is not given. Then that kind of function is simply called as implicit function. Means you cannot write one of the variable, you cannot differentiate which is dependent, which is independent variable. Called as implicit function. How do you solve that? There will be a process for this. You have to use chain rule and product rule as well. Have a look. So start differentiating from here. You're looking for dy by dx. What it means is simply y dash. Your means is simply y dash. Okay. Let's continue from here. Differentiate this. You have x cube. Differentiation becomes 3x square. Derivative of x cube is 3x square. Okay. Derivative of, I have to take some more space. Excuse me. Okay. Alright. Derivative of x cube is what? 3x square, sir. Plus, that is over. Derivative of this, can you just do it directly? You have to use the product rule. Differentiate x square first, you're going to get 2x, keep y as it is. Differentiate x square first, keep y as it is. Plus, okay. This time, keep x square as it is, differentiate y, you'll get for y as y dash. Derivative of y with x is nothing but dy by dx. That is simply y dash. I can write dy by dx as y dash. Derivative of y is what? Y dash. Next, this term is over. This 2 is from this term only. Okay. Next is this term. Again put a plus sign. Differentiate xy square. Again product rule. Keeping x derivative will be simply 1. So 1 times of y square. Derivative of x is simply 1. Y square is kept as it is. Plus sign will come. This time you're going to keep x as it is. Differentiate y square. You're going to get what? 2y. Is it over? No. 2y is not the right answer over here. You have to differentiate what? Y also, right? Right now you have differentiated y square. Derivative of y square is 2y. Okay, very good. But derivative of y is where? Chain rule you have to apply. So 2y, y dash. Are you getting it? Derivative of y square is 2y. What about y? Derivative of y is y dash. Now you might ask, sir, derivative of x square is 2x. Where is derivative of x? Derivative of x is nothing but 1. That's why we don't write it. But derivative of y is what? Derivative of y is what? Simply y dash. Got it? Clear? Clear? Okay. Next is what? Y cube. Differentiate y cube also. You'll have 3y square. Is it over? No. Differentiate y also. So y dash. Derivative of a constant 81 is 0. Is 0. This is clear. Next. Okay. Next step would be to simplify, because we are looking for y dash value, right? So we'll keep y dash term on this side and rest all will put on the other side. So y dash terms, where are the y dash terms? We have here, here and here. Okay. So I'm taking y dash common. What is left over here in the first term? X square is left. Over here what is left? 2xy is left. Over here what is left? 3y square is left. I've taken y dash common. Okay. Other terms are moving on this side. It will become minus 3x square minus 2xy and minus y square. Sir, you're not writing minus, you're just saying it. I can keep it outside, na? I can keep it outside. That's why I'm not writing it, okay? These terms are all positive. Goes on that side, becomes all negative. So I can keep the minus sign outside. So my value of y dash is nothing but, have a look, minus 3x square plus 2xy plus y square divided by, check this out, this whole thing will come in the denominator. So you'll have over here x square plus 2xy plus 3y square. That's your answer. This is my final answer. Is it okay? Is this all right? Is it acceptable to all of you? All of you understood this question. Different ways to ask you, but means the same thing. Yes, sir, understood. I want the comment. Yes, sir, understood. Question number 4 is clear or not? Yes. So it's a question on implicit function, very useful in your boards. This is question will be very, very useful in the board segment. Okay. Can I move on now? Question number 5. Okay. Notes you'll get in the class, in the PDF format of WhatsApp. Go ahead and join it. Find dy by dx sin square y plus cos of xy. Again, it's an implicit function. There's no subject given. We have to use the same approach. Okay. Let's do it. Differentiate this part. You'll have this as 2 sin y. Derivative of sin square y is 2 sin y times of derivative of sin cos y. Sir, you already differentiated sin, sir. I did not. I differentiated sin square y. So I got 2 sin y. Now I've differentiated sin y. I got cos y. Is it over, sir? Of course not, sir. You have taught us now. Differentiate y also. We get y dash. Yes. What about this side? Derivative of cos, sir. What is derivative of cos? Minus sin. Derivative of cos is actually minus sine of that given angle. Okay. So minus sine of the same angle xy. Is it over? Apply the chain rule for xy also. So derivative of xy will be what? Let's see the product over here. Derivative of xy means, I can write it like this simply. Derivative of xy for this step, and for pi you will have 0. For pi you will have derivative of 0. I'll show you this, how to do derivative of xy in the next step. Okay, this first step is clear, right? This first step is clear. Yes. Derivative of cos is minus sine xy, and the derivative of xy will be continuing from here. So I get 2 sin y cos y dash as it is minus sin xy, and over here what I get? Differentiate this. So I get to differentiate x first. I can do any order. I get x as 1, y as it is, plus x as it is, y dash over here. Okay, plus x as it is, y dash over here. Now I want the y dash terms together, so I have y dash over here and over here. I have to multiply this with sine also. So let's just do that. I'll keep the y dash common. 2 sin y cos y. How much is that? Sin 2y. 2 sin y cos y is sin 2y, not sin square. It is sin 2y. Sin 2y. Okay. And what is left? That is it. Over here we have, if you take common, you'll have minus sine. You'll have x sin xy. Correct? This x will become minus x sin xy. And what is left now? we have here minus sine xy into y left equals to 0. Okay, I'll move this term on the other side. What I get, please check. My final answer is coming your way. Y dash equals to sine of xy with y I can write here, y is outside, this y is outside, divided by this whole thing, sine 2y minus x sine xy. Please cross check, guys. If I made any mistake, let me know. Okay, y minus y sine xy upon sine 2y minus x sine xy. That's my final answer. I hope you all got it same. So you have to solve the questions with me as well. You can pause the video and solve the questions. Just for example, for the next 5 questions, you have to solve all of them, solve it, then come back and check my solutions. Okay, this is clear. Y dash is y sine xy upon sine 2y minus x sine xy. This is clear. 5th one is done. Question number 6 now. X square plus sine y equals to y square plus log of x plus y. Again, find the derivative. How do you find that? Okay, I'll do the first statement and there will be homework. But it will be difficult for you to give the answer, right? Okay, I'll solve this one. It will be difficult for you to give the answer in the comment section for this one. There's no option given to you. Okay, so I'll solve this question. Let's not give you as homework because we don't have any option over here and it will be difficult for you to type all the answers. So I'll solve this one. When I have an option question, you have to solve that. Okay, so what I get for this, differentiation of this will become 2x. This will become what? Plus sine y will become cos y. Is it over? No. Right here y dash also. Sine y derivative is cos y, derivative of y is y dash. This side 2y is the derivative of y square, derivative of y will become again y dash. Log derivative is what? Reciprocal. Log x is what? Reciprocal. Okay, acha, whenever in the question, whenever they say log, they are actually meaning a natural log actually. In the questions for your board, when they say log, they mean actually this thing only, natural log. Okay, so take it as natural log. 1 by x plus y. Now derivative of this part. I'll write here derivative of x plus y. I'll solve this in the next step. Okay. What I get? I get 2x plus cos y. Can I move the terms? Okay, I'll do that later. Cos y y dash equals to 2y y dash. Okay, and this over here will become 1 by x plus y as it is. And derivative of this, derivative of x is what? 1. Derivative of y is what? Y dash. Derivative of y is what? Y dash. Okay. Now I want to keep the y dash term on one side and other terms on this side. So have a look. 2x are over here only. And what is this term? I have only one term which is not having y dash, is 1 upon xy on this side. 1 upon xy into 1 is what? Into 1 is 1 upon xy only. So I will just move it on this side. We'll get minus of x plus y. Minus of x plus y. Okay. And this will become what, dear? I can take y dash common now. I have over here 2y and we have over here plus 1 upon x plus y. In the y dash you have still multiplied with 1 upon x plus y, right? So we have to write that, and this cos y will come on this side. So minus cos y. Minus cos y. Is it clear? Is it over? No. Have to take the LCM also. LCM will become over here what? X plus y. So this will become 2 times of x with this. So it will become 2x square. 2x multiplied with x is 2x square and 2x multiplied with y is 2xy. And of course there's a minus sign. There's a minus 1 sign as it is. Okay. Moving on. We'll still have y dash over here. Take the LCM one more time. Okay. I get this will become again 2xy. And y into y will become 2y square. 2y square. And plus 1 we have. So plus 1. And the last one will be what? Minus x plus y times of cos y. Minus x plus y times of cos y. You have x plus y over here and over here as well. Cancel it. Cancel it. Now I want to find the value of y dash, right? I want to find the value of y dash. So my y dash will become equal to what? This number over here, 2x square plus 2xy minus 1 divided by this whole numerator on this side. Same thing. So we have over here 2y square plus 2xy, the first two terms. Then we have plus 1 and then we have minus times of x plus y cos y. X plus y cos y. X plus y cos y. 1 second. Okay, 1 second guys, let me make it separate column over here. That's a final answer. Please check. 2x square plus 2xy minus 1 in the numerator and 2xy square plus 2xy plus 1 minus x plus y times of cos y is my final answer. Okay, that's why I did not ask you to solve it. You'll get too many steps to write in the comment section, difficult for you. Okay, I'll give you option 1, don't worry, we have that also. Question number 6 is over, no doubt. This one. Okay, this is your homework. This is your homework. So solve this question and give me the answer. Okay, you can solve it. Solve and comment your answer below. Come on, do that. You can do it right now also. If you want, you can pause the video and give me the answer right now. Okay, can I continue? Please solve it, I'll continue. Okay, 7th is done. Question number 8. If we have again x times of root of 1 plus y and plus y times of root of 1 plus x equal to 0, then what is the derivative of x? Derivative of y with x. Okay, basically y dash only they're asking. Now in this only we're going to use the property, the trick for the what you have, the quotient rule. We'll see that. Okay, so first of all let's move this term over here. Let's move this term over here. What I get? So I get here x times of 1 plus y equal to minus y times of root of 1 plus x. Square on both sides. SBS square on both sides. What I get? Square on both sides. Have a look. So I'm getting over here x square root of 1 plus y. Because root is gone now. There is no root. S square times of 1 plus y. Over here y square times of 1 plus x. There's a mistake. I've written here x square. I have to remove that. I've made a mistake over here. This is not x square. Okay. So y square times of 1 plus x. Now can you see we have y square times of 1 means y square. So I'll keep the y square term on this side. So I get what? X square minus y square. Please check. I'm moving this y square times of 1 as y square on the left hand side. And what is the left term over here? The term that I have left with is y square x minus this term x square into y. The term x square into y will move on that side. So I get here x square y. X square y. Okay. Let's do one thing. Take xy common. So I'll have here y minus x. I'll have here y minus x. Okay. You don't have to do it all the steps. You can do it in your mind also. Not a problem. I want to show you. That's why I'm doing all the steps. Okay. And now check this out. X minus y and y minus x can be cancelled with a minus 1. Because there's a difference in sign, right? That's why we are writing here minus 1. What I get? I get x plus y equals to minus xy. Minus xy. Let's keep the y terms together. So move this whole term on this side and this x on this side. Look at my steps very clearly. What I get? I get here y plus xy equals to minus x. Y plus xy equals to minus x. Let's continue. Let us continue from here. What I'm getting now? So I can take y common. So I'll have x plus 1. Over here we'll have 1 plus x or x plus 1 equals to minus x. It means the value of y is nothing but minus x upon 1 plus x. Now you can do the quotient rule or simply use the the trick that I taught you. Y dash equals to, what is it? We had 1 plus x square in the denominator. Okay. And whatever is the function given over here, derivative of this function, what is this function? Simply derivative of x. And what is the constant over here? Minus 1. If you solve it, no, the formula for determinant, you'll get this as minus 1 only. Answer will be minus 1 upon 1 plus x square. I'll have some water. Okay, let's continue after that. Okay, sorry for the break. All right, so what we have, what did I say? The coefficient is what? What's the coefficient? The coefficient is simply, if you check, over here we have this as minus 1. There's no other coefficient, so we have 0 over here. and for this we have 1 and 1. So 1 and 1, please check. 0 into minus 1 will become simply 0, and 1 into 1 will be simply 1. There's a subtraction which will make this as minus 1. If you do not want to do all of that, simply apply the quotient rule. I'm telling you, apply the quotient rule. Apply and get the result. Answer will come as minus 1 upon 1 plus x square. Minus 1 upon 1 plus x square. Option C is correct. Okay. Do one thing, please cross check using the quotient rule. All of you, please, my dear, check using the quotient rule and let me know whether the option C is coming or not. Whether the option C is coming or not, please apply the quotient rule and give me the answer. Okay. This is my final answer. 1 minus 1 upon 1 plus x square is my final answer. Let's move on. Question number 9. Now y equals to we have root of a square plus x square. Then find the value of derivative. How do you find that? Same thing, square on both sides. Square on both sides. Reason is very simple, because we have roots. That's why. So what do you get? You get here y square equals to a square times of, not times, plus. There's a mistake. It's a plus, not times. Okay, so a square plus root of a square plus x square, right? Yeah. Now bring this a square on this side, so I get here y square minus a square equals to a square plus x square. This is my first equation. This is my equation number 1. Now again square on both sides. Sorry, there's a root over here, okay? Now again square on both sides. When you do that, you have here y square minus a square, the whole square equals to a square plus x square, okay? Now in this case, after the roots are gone, you can differentiate. What are you going to get? Differentiate on both sides. So you'll have here 2 times of same thing, y square minus a square, okay? Is it over? No. Differentiate the bracket also, this bracket. So for differentiation of y square will become 2y y dash, 2y y dash, and for a square will be simply 0. So minus 0, we don't have to write that. Okay, this will become 2y y dash, and for this side we'll have what? We'll have this a square as 0. This will become, this x square will become what? 2x. Will become 2x. This 2 over here and this 2 over here is cancelled. Take the final answer. What I'm getting? I'm getting this y dash equals to x upon 2y y square minus a square. Y square minus a square. We have that value of y square minus a square from here and y value from here. So use that in this, no, right here, 2 times of this value, y value, and this value over here. This value y comes from this place and this value comes from this place. Substitute and get me the answer. Substitute the value of y and y square minus a square from the given 2 statements over here and over here. That's your final answer. That is your final answer. Question number 9th is done. Question number 10th now. Question number 10th now. Okay. So again, I will not give you the final answer. I'll give you almost all the steps, but final answer has to be coming from your side. Question number 10. Options are there. You have to solve it. Okay. Y equal to 1 minus cos x. So simply take this formula. 1 minus cos x is what? 2 sine square x by 2. Trigonometric function PU1, 11th grade. 2 sine square x by 2 is the 1 minus cos x formula, and 1 plus cos x is given by 2 cos square x by 2. From where this formula comes? This over here. Cos 2x is given by 2 cos square x minus 1, or 1 minus 2 sine square x. Whichever formula you want to use. This is the same formula. Just replace x by x by 2. Okay. 1 second. This is sine square. So the formula is this: cos 2x equals to 1. So 2 cos square minus x, 2 cos square x minus 1, and 1 minus 2 sine square x. Use this formula. That's where this formula comes from. If you don't remember this one, simplify. Just replace this 2x. Just replace this 2x by x, and this x by 2. X becomes x by 2 and 2x becomes x. Okay, got it? So we have here 2 formulas. If you use that in the root, what you get? You get y equals to root of 2 sine square x by 2 by 2 cos square x by 2. 2 and 2 is cancelled. I get simply this as tan square of x by 2 in the root. Root will cancel the effect of the square, so answer is simply tan of x by 2. Now I want to give you the answer. I don't want to give you the answer, you have to solve it. So from here, comment your answer. Comment the final answer. Homework. Do it and let me know. Question number 10 is done. Your session is today over. Question number 10 is done. Comment your final answer. Okay, this is clear? Had fun? Was the session interesting or not? Did you learn from it or not? Okay, seriously tell me. Any other feedback you have to let me know in the comment section only, because in the lives, if we had right now, you could have said to me all the information you could have given me, shared with me, but right now we are not doing it. We are doing it in recorded format. So your comments plays a very big role. I hope this is clear. So your comments becomes very, very important, because how can I interact with you? Through your comments only. So anything you have to ask me, leave it in the comment section. You want something different in the sessions, leave it in the comment section. Okay. So with this I can end the session today. I hope you had fun. I hope you learned something. You cracked these 10 questions with me, and don't forget to give me how many questions you got it right. I want to see for every person, like I'll know the name, right? When you comment, how many questions you are improving every session. If not improving, what is going wrong? I'll ask you all of that in the comment section only. So leave all that information with me. How many questions you got right in this session? Okay, 9 out of 10, 6 out of 10, 8 out of 10, whatever it is, give me that number. So with this I can end the session today. I had fun teaching you all. I'll again come back in the next session with another beautiful session that you will enjoy for sure. My guarantee for that. And for now I have to say bye. Take care of yourself. See you again very soon. Till then, of course, take care of yourself and bye bye.